This video will show my implementation for project 1. I am TangHuyming, and this is my implementation in C++. So I have two header files where I implemented my PCBs. Both versions are marked as 1 and 2. For the first version, I created a struct to store the nodes for the children linked list. I also created a struct for each PCB, and I created a class for the PCB array. So in the class, there's a constructor that takes in number of processes. This will be used to create the new dynamic array. And inside the constructor, I also mark PCB0 as occupied because that is the assignment. And I also have a destructor for destroying the dynamic array. For my create function, first I check whether or not P is free or is a valid parent. If P is less than 0 and greater than size, then it's not valid. Or if the slot is free, then it's not valid. There's no parent there if it's free. Then I check for a free slot for my child. If there's no free slot, I just return canceling this error message here. When a free slot is found, I create a PCB child, I append that child to the PCB array, and then I create a linked list node and attach that to the children linked list of the parent. To do that, I check if P has any children. If P has no children, then the head of the linked list is that new node. If there's children, then iterate through children until you find the last children, then append that new child. For my destroy function, I check if P is free and valid, and then I recursively destroy all children using this section here. So I assign the children of P to current, and then I recursively iterate through the children until I find the last children, and then I delete it, and it goes back up to the next child, and it keeps going until there's no more children left, or all children are destroyed. For each iteration, I also mark the PCB slot as free in order to make room for a new PCB. Okay, and this function is just there to debug. I have it there to debug. For my second PCB version, it's a little different. Instead of having a linked list to children, I have 3 integers: first child, a younger sibling, and older sibling. My PCB array is the same for the second version. My constructor is also the same. The structure is the same. For my create function, up until the free index check part, is the same, but my children, the way I append children is different. So I create a child process and I add it to the PCB array, which is like the first version, and then I check if the first child is occupied. So if P's first child is occupied, then I find the youngest sibling of P's first child. And if it's not occupied, then I append the index of the new child to the first child attribute of P. I also make the older sibling of the new child the first child of P. It's a little confusing. That's what I did. I basically connect them all together to make sure that my destroy function can go through them without having any issues. For my destroy function, I also do a recursive destruction. I recursively go through all the child, destroy every descendant up until the child, and then remove that child. The only one that's not destroyed is P itself. So same here. See if it's a parent. If it's not a parent, because -1 is parent. So if it is not a parent, then free it up. But if it is a parent, then don't free it. Parent is basically the first process that calls this destroy function before any recursive calls. My tests, I followed the video. I basically created something similar to the video, but instead of having one test function, I have 2, and I named them 1 and 2 based on which PCB they use, which PCB version they use. And I calculate the linked list time and the no linked list time, find the difference, and that's the time saved. So let me run this again. All right, there we go. Linked list is much slower, well, 85, 86 milliseconds slower than no linked list. All right, thank you for watching. I hope I make sense. This assignment was challenging.